Welcome. In this video, we are going to review concepts from Learning Target 3.1. We're focusing on the periodic table and the families in the periodic table and metals and nonmetals and related concepts there. So first, to give us some context, we are talking about elements. Elements are the building materials of all matter. So we're showing some Lego blocks because they're like the building blocks of matter here. There are over 100 known elements. Elements can combine with other elements to form compounds, and all matter is made of some combination of either elements, compounds, or some mixtures of those things. All right. And each element has both a name and a symbol associated with it. That symbol might be 1 or 2 letters. So some examples that you might be familiar with would be like carbon. The symbol for carbon is a capital C. The symbol for oxygen is a capital O. And so those are examples of having 1-letter symbols. The symbol for calcium is, well, C is already taken, so the symbol for calcium is capital C and lowercase a. The symbol for cobalt, which is a metal, is capital C, lowercase o. So notice how if I wrote capital C, uppercase O, that would imply I had carbon and oxygen. But if I write capital C, lowercase o, that would be the element cobalt. So it's important to pay attention to whether a letter is capitalized or not. So each element symbol is just going to have one capital letter in it. So here's some examples down here of some other symbols. So like zinc is capital Z, lowercase n. And then some of these symbols might not seem to make a lot of sense, like sodium. Why is the symbol for sodium Na? Or why is silver Ag? It's based on their excuse me, it's based on their Latin names. So the Latin name for sodium is natrium and silver is argentum. So that's where those symbols are coming from. The periodic table, excuse me. So the periodic table shows all of the known elements. You can see all the element symbols here. So there's cobalt right there. There's carbon, there's oxygen, there's silver. And we can break down the elements into 3 categories. So the metals are the light blue on this table, the metalloids are the orange, and then the nonmetals are the ones in green. So that's one type of grouping. We might say metals, nonmetals, metalloids. You'll notice the majority of the variety of elements are metals. So there's more metal elements than there are non-metal elements in terms of, the variety here. And another way in which we might break these down into groups is we'll look at these vertical columns. So if you look at elements in vertical columns, those elements tend to have similar chemical and physical properties. And we can explain that by looking at their atomic structure, which we'll cover in a different video. But for right now, we'll just say things in the same column have similar properties, and so we tend to give them names. So like over here, everyone in the first column, we call those the alkali metals. That's lithium, sodium, potassium. Then we have the alkaline earth metals. In the middle section, the transition metals. And then we have the halogens and the noble gases. Some of these in the middle, they don't have a particular group. And maybe they don't have as many things in common in this column as opposed to like the halogens. So some of them don't have a special group. So let's kind of break down what's happening in each group. So the alkali metals, they're in this first column right here. The alkali metals are the most reactive metals, and they react violently with water. So when you put sodium in water, it will be very explosive. And in fact, as you go down the column, they become more and more reactive. So those alkali metals at the very bottom are the most reactive. Alkaline earth metals, that's 1 over. There'll be some metals here you're familiar with, like magnesium and calcium, I'm sure you've heard of before. So they're in the second column. And they also will react with water, not as strongly as the alkali metals, but there's a similar pattern where as you go down the column, they do become more reactive. The transition metals are this big group in here in the middle, and a lot of the metals we're familiar with from day-to-day life are actually transition metals. So some examples would be copper, gold, nickel, and iron. Those are all transition metals. And over here on the non-metal side, let me go back to this visual. So the non-metals are up here on the upper left, remember? And non-metals could be solid, liquid, or gas. So their state of matter can vary. I've included some pictures here of some of the non-metals that are solids at room temperature. So carbon is a non-metal, phosphorus, selenium, sulfur, they're all non-metals. And then within the nonmetals, there are some groups like over here, the halogens, they're all nonmetals. And the halogens are the most reactive of the nonmetals. We've got fluorine, chlorine, bromine, iodine are halogens. And we'll find over here with the nonmetals that the more reactive ones are actually in the upper right-hand corner. So the most reactive metals are down here, like your cesium and your barium. The most reactive metals are, sorry, most reactive nonmetals are in the upper right-hand corner of here. Like fluorine's the most reactive. And here's some examples of some of our halogens. So like chlorine is a gas at room temperature, that's chlorine, and then bromine is one of the few elements that is a liquid under standard conditions. That's what bromine looks like. The noble gases, these are this last column. So every element in this family are gases, and these elements are very unreactive, and they're helium, neon, argon, xenon, and then we'll talk more with structure later on about why the noble gases tend to be so unreactive. Metalloids are the in-betweens. They're right here along this line. They have characteristics of both metals and nonmetals. One example of a metalloid would be silicons. This is a little picture of silicon there. And it's very common. 25% of the Earth's crust is silicon. And the other metalloids are like boron, germanium, arsenic. So those are your other metalloids in there. So a sample problem. What group does the atom fluorine belong to? So you want to be able to look at the periodic table and know your groups here. So fluorine is over here, and oh, my pen's not working. And it looks like fluorine is a halogen. All right, so it is a halogen. And we know that things in the same group will have similar properties. So if I'm asked what's another element that would have similar properties to fluorine, I might say chlorine or bromine. Something else that is also a halogen might have similar, reactivity. And give an example of a metal and a non-metal. So anything over here on this side of the table is going to be your metal. So I might say a metal, I could say K, which is potassium, or Fe, which is iron, or Cu, which is copper. So any of those would be good. Non-metal, I'm going to pick something on the upper right-hand corner. So like nitrogen or helium or bromine. Those are all examples of non-metals. All right, thanks for watching.